Hi, my name is Chirasri, and I'll be walking you through problem 3 on worksheet 13. This problem is about tries. Tries are a tree-like data structure that we use particularly on strings for search and prefix operations. So an example of interesting use for a try is when you're typing into Google search, that's supposed to be a search, and you're typing in the word, let's say LA. What Google could do is it could go into their own try of all possible search results. Maybe it looks like this, and give you back all the words that start with LA as possible autocompletes that could go here. So that's some motivation for why we might like tries. So with tries, we work with a predefined alphabet of size R. So this is And when we also talk about runtimes with tries, we like to think about the length of the string that we're querying, searching for, or adding. So that's going to be L. So the last thing I wanted to discuss with tries is that every node can have a node after it to represent the next letter in a word or a prefix, and then we denote the end of a word by a special character, in this case an asterisk, or maybe it's a Boolean flag or the color of a node, and this is going to let us know how to retrieve words when we come and search the structure. So let's go to the first question. It asks us to retrieve all the words in the try. So I'm going to go in with a purple highlighter and highlight all the words. So you kind of essentially go in depth first order when you find words, and there's a nice organization to it. So we know that all the words in this try start with L because that's the first node, right? And then we branch off into A and O. So let's do the A words first. And then from there we branch off into V and M. So we're going to have some words that start with LAV, some that start with LAM, and some with LO. Of LAV, there's only one, Lavar. For LAM, we have LAME, so lame, and also lamello. And then for LO, my bad, for LO, we've got just one word, Lonzo. So the next question asks us to insert Leangelo and Love into the try above so that no big baller is forgotten. So we want to enter Leangelo and Love. So we know that Leangelo it definitely starts with L, so we've got that in common. So then the next character I is going to be a child of L. Either it exists in the try, which it already doesn't, so we have to create a new one. And then from there, we're going to have to create new nodes for every subsequent letter in Angelo. And then put an asterisk at the end to denote the end of the word. So that's Leangelo. And then love is a different story because we actually do share a longer bit of the prefix of love. We have LO already in the try. So then all we have to do is add the V and the E and put an asterisk at the end. So that's Leangelo and love. The next question asks, how long does it take to add n words, each of max length L? So we added 2 words in the previous problem, and it looks like we did approximately the same amount of work proportional to the length of the input for both of the words, even though one had a longer prefix in the try already and one was a relatively distant word, like Leangelo, didn't have that much in common with the try. So what we do know about adding a word is we're going to do L work for each word we add, because, maybe it's the case where it's like loved with a D. We're going to need to traverse all the way down love and then add that extra node, right? Or it's the case of Leangelo, and we have to create almost like L-1 new nodes to add to the tree. So either way, we're going to be due proportional to n be doing a proportional to L work. And then if we have n words, the runtime is going to be n times L. The next question is also about runtime. It asks us for the best and worst case runtime to check whether a word of length L is in the try. So searches and add operations are going to have similar runtimes because you need to search while you're adding something. So the best case, let's think about that. The best case is when our word is actually not in the try or shares very few, like within the first few characters of the word, we know it's not in the try. So an example of this would be the word ball. And we know that ball is not in this try because it's simply not, we don't have that letter option to start with for B. So we would stop right away and we would have constant time. Look up for that. And the worst case on the other end of the spectrum is the word is in the try because we're going to have to traverse, let's say we're looking up Leangelo. We're going to have to traverse the length of Leangelo all the way down to the end character to confirm whether or not it actually is in the try, apologies. So that's going to be a theta L operation. There you have it.